Cool. So, quick overview. So, my name is Blake Tucker. I'm an iOS engineer on the Amex Mobile app. I've been on Core Mobile for almost a year now, and before that, I was doing internal apps for about a year. And before that, iOS was a hobby and something I did in my undergrad at ASU. The fine lawyers at American Express have asked me to clarify that I am here speaking on my own, and my opinions do not represent the company. So, all right, I checked my box. All right, so RxSwift, kind of a new library. It's kind of on par with things like reactive Cocoa, but more importantly, what is functional reactive programming? So functional reactive programming is all about doing things asynchronously. So it's more of your code operates on event streams. So events are things like taps in the app, or user clicks, or you have a data stream coming down from the web server. And essentially, the goal of the Rx project is to simplify your code by, instead of modeling against state, you model against time. So all of your observables will act as like reactions to an event stream. So an event can run out and just like either error out, or it just runs out, and the observer signifies that I am out of events, and the code base will react to that accordingly. So I found this handy diagram that kind of shows how this works. So events can kind of go in any order. So you let your event go through, you process as you want. If there's an error, you can either handle it, or you can let it fail, or you can just let the events go through. So this is like kind of like all well and good, but I have Xcode that automatically populates templates for me based on my delegates. So why should I care? So state in an application is a pretty terrible thing. So let's take like the basic example of I have a calculator app. How many states are possible in a calculator app? You can be adding numbers, multiplying numbers. How many numbers are there in a sequence? State becomes essentially an exponential problem very quickly. But you can handle all of this. It essentially all boils down to the same thing. Like, these states are just representations of user input. So why can't I take the input portion as a string? Rx also acts as this very awesome abstraction layer. So in Swift, you already have things like protocols and inheritance and composition that have carried over from the object-oriented world, and they're pretty impressive. But this lets you take abstraction one level farther. So instead of concerning about I have a UI table view and I want an autocomplete to filter my table view, you have to implement a few delegates, a search method, and then maintain the state of your data. RxSwift will handle this for you. You also live in a world where expectations from your users are much higher. Back in 2007, when the first iPhone came out, the expectation was just oh my God, this thing works. This is amazing. This is this brave new world of technology. I can touch something on a screen and it reacts. Just being able to touch it was the delighter then. That's not a delight anymore. That's an expectation. So as the technology community and technology have improved, our users have wanted to do things much more quickly. So this means you have to develop your app faster. You have to ship changes faster, more features faster. So Rx, for whatever platform you want to use it on, lets you essentially ship in real time, because you no longer have this idea of state when you come to test your application, or this idea of I'm going to have a manager class that's going to manage this object. That's a very bad thing, and then it comes back to bite you very quickly as your code base ages. So Rx is basically a very fancy implementation of the observable pattern. So anyone who's ever done Java or C# before will be very familiar with the observable pattern, because it's basically how Java wants you to do things, but not how most people do them. The idea behind the observer pattern is you, as an object, subscribe to notification. So you say I want to know when this value changes. It's kind of similar to if you've ever studied operating systems. If you look back at operating systems in the 60s, 50s, and 70s, you end up with a system where everyone's polling constantly, going what's your state? Do you have data for me? This is very intensive. It slows down your system. There was a paper from, I believe it was Stanford at the time, when they were doing research on it, that they found that 70% of their CPU usage under these systems was used just by polling. So you're not really gaining anything out of it. So this idea came up of, why can't this thing tell me what's happening? So in operating systems, you'll see this quite commonly. If you go like to open source page, like the Darwin kernel, you notice that everything just notifies when something changes. It doesn't ask for you to request a change. So at like the core basic, this is what Rx is. We're just telling, we're waiting for the object that we care about to tell us what's going on. So Rx is based around these things called observables. So observables are also kind of called sequences, but they're essentially like queues. They're just push and pull events that happen within an object. So a text field has an observable. All you care about there is what's the value in the text field that this user is inputting in. So all you really care about like at that point is, I want to know when this changes. I want to know when the user pushes data in, and I want to be able to pull it out. Observables are 0 to n objects. You can have an observable that hasn't done anything yet, or you have an observable that has every value known to man and just continuously reading it to you. So in code, this kind of looks like this. It's pretty straightforward, as you're kind of looking. If you kind of think of it as like a singly linked list, where we request the next element, we handle an error, or we mark the event as complete. So that's all I can have with observable. You get the next event, it kills itself, or it tells you that I errored out. How do you really like care about this? All objects in RxSwift will, at some point or other, inherit or implement this observable class and this observable method of subscribe. And any like data source will will adhere to this protocol of observable type, where on this event happening, I need something to happen. I needed to either tell my subscribers, I needed to handle something internally, I needed to do something. So if that didn't confuse you at all, there are actually two types of observables. We have this idea of hot observables. So hot observables are anything that we kind of don't know the outcome to. They're web requests, they're user inputs, they're taps, they're essentially anything. They can be stateful, but state in Rx is slightly different, and that is basically the state of, I have an event, I've completed, or I have an error, or I have nothing. So that's all you can try to program against versus like if you're in calculator, infinite states. Hot observables exist in memory at all times. They're all based on essentially this computational idea, and they maintain all their resources once. So if I have a class that subscribes to an event, or an object that subscribes to an event of a hot observable, I'm not creating any new resources in the system. I'm saying this resource exists, I'm telling it that I want it to tell me something, and then if an event happens, it'll tell me. Cold observables. These are kind of like one-off things. So if you say you have like an NS operation and you're going to put something on like your background queue, you're going to do it through a cold observable because it's basically going to do one thing. It's going to tell you it finished, or it's going to turn back some result to you when it's done processing. These are stateless because you don't care what state it's in. You just care that it completes or it errors. You'll see this mostly used in like background network requests, where you don't want to block the user thread, and you're just going to say, this data will come when it comes, and then I will update it accordingly. These are usually only one element of observables. So it's like a one-time request of, I want this JSON object to come back from like the Amex web server, or from GitHub, or from Wikipedia. But these are computationally more intensive. The more people who subscribe, the more resources it'll consume. Because since it doesn't have state, it only exists when it's complete. And so if you have a billion things subscribed to it, you're going to have a billion instances of it that will all live and then die simultaneously. So everything in Rx is a stream. So once you kind of like wrap your head around this idea of instead of treating data as something that can happen, anticipating it happening, and letting it happen, and letting your business logic or your just logic of your application handle it versus writing all this boilerplate code, you feel better. So let's look at some boilerplate code. So this is a autocomplete function in Swift. So if you are using Xcode right out of the box, you say, I have a UI text field. First, you have to describe to the UI text field delegate. Then you need to implement these delegate methods. And say updating a table view, you now have a table view delegate, and you now have table view data source because you're now changing the data source. So you now subscribe to 3 delegates, and your view controller hasn't done anything. So let's kind of step through this. So we have a UI text field. We subscribe to the, or we've implemented the should change characters in range. We've let the foundation library handle when we're called. And all we ask is that we then review this table view, we turn off hidden, and we start processing this data. So by implementing this, this delegate, we've essentially gained nothing. We've written all this boilerplate that didn't need to exist. And then we pass ourselves down here to our logic for how we're going to search for something. But in a non-reactive, non-extended environment, you then have to manually tell your table view that you want it to reload versus it knowing automatically that its data source has changed. And then we have to re-implement all the table view methods as they are. So we kind of write a lot of code to do not a lot. So let's kind of step through how you do this in Rx. So here's our search function. Does the exact same thing, except we've done a couple more things. So we've automatically auto-completed everything by setting this search bar to this .rx method extension, and we start creating our query. So let's kind of break this down just a little bit more. So our search result. So our search bar is just a standard UI search bar. But in reactive, in RxSwift, any function in UIKit will automatically have these .rx extensions as required. So here, we've created this thing called .RxTest. So all this is it creates an observable stream for us to subscribe to based off the value that's being presented inside of this search bar. And then we add this like as driver method. So I'll cover what a driver is a little bit later, but essentially it buys us priority. So instead of us doing manual scheduling on a background thread or the UI thread, the driver handles that for us, and it automatically handles collisions and deadlocks. So it's pretty nifty. And you get that for free just by using the library. So then we add this .throttle method. So in our Objective-C implementation, we didn't have this. So what we're doing is in RxSwift, you have this idea of throttling. So this is really good if you're making network requests or if you're processing user input for autocomplete into fields that have lots of data. So we say .throttle, and it's how many seconds you want to wait between requests. So if you don't want to do this, essentially a new request will be created every time the user taps into the field. So if you have a user who's like 100 words a minute on their iPhone keyboard and they're writing 100 words, you're going to get a ton of requests, and you could potentially buffer overflow your application, causing iOS to kill it. So we do this .throttle. So this automatically tested, automatically installed, lets us limit how fast we're going to look for data for our user, so that we can maintain the performance of the application UI and ensure that iOS does not kill us for exceeding our memory constraints. Then we also use distinct until changed. So if the user, say they were typing and they typed one extra letter and then they backspaced in that same time, we're going to get this notification from Rx that the value has changed in the time that we've observed it, but here's the previous value you had. And distinct initial change automatically checks what value we had before, and if the changed event doesn't lead to a changed result, we don't search again. So we've automatically reduced a request. And those of you who've used Swift, before, it's this idea of flat map. But in Rx, we get this idea of flat map latest. And so what flat map latest will do is if we're getting a ton of requests, it'll actually start to kill off the ones that are already running on the old values. And so it maintains its own priority queue and it sees the stacks. And so if it sees that a user typed in like APP and then finished LE like 0.3 seconds later, it'll kill off that request and just process the Apple string. We use more of these drivers and more of these states. We also have this idea of being able to trigger other things through shared APIs, but I'll get into that a little bit later. So right now, let's talk about drivers.
Sorry, I think there's construction upstairs.
It's like I've learned the city is like perpetual construction.
Just 2 seasons, winter and construction.
It's good to know. So here's what a driver is. It's essentially a way for the reactive library to control what thread will process on. So you can customize your drivers. There's a fully extensible library on the RxSwift GitHub page that just walks you through completely how to create your own driver, how to create your own like background process thread, how to prioritize yourself if you want to do that. But the standard driver will let you run code to the UI layer. You really only want to write to the UI layer if you're actually processing something that the user needs to immediately see. This doesn't just go for Rx, this goes for all iOS development and Android development too. You should do as little processing on UI layer as absolutely possible, because if your experience locks up, the user leaves your app and they're not happy. Drivers also buy us the ability to kind of collapse this idea of responsive programming. So if I have tons and tons of threads running or tons of jobs queued through my observables, and the latest one finishes and there's still background ones running, it'll automatically collapse those down and take care of that memory management for us. And by default, these do run on your main thread. So there's a configuration that comes with it that runs on the background thread, but that's listed in their API. And I would discourage you from using drivers when you're not on the main thread, because scheduling is not really a problem at that point. The iOS foundation system is very good at scheduling what needs to be scheduled, so you kind of don't need to force yourself on it in any way to reprioritize what you want to. Unix is very good at that, and Unix has been doing it for a very long time. So unless you know for a fact that your way is going to be better, I would just trust the system. In reactive, we have this idea of dispose. So dispose lets you, when you call this, it lets you immediately terminate the sequence, whether or not it's finished telling you what's going on, or if there's still events coming. It just lets you stop caring about it, and it releases the memory back into the system. So dispose is pretty good at what it does, but a driver also will take care of this for you. If you run something with the driver, it'll automatically dispose itself when the user's done with it, and it doesn't need to exist on the screen anymore. But let me kind of show you how this works in practice. So let's say we've subscribed to something, we've subscribed to this stream of things, and we just want to print them out. I apply this NSThread sleep just because I want some events to fire first. And then I'm going to call a subscription.dispose. So what I've done here is I've let some events fire, and by letting it fire for like 2 seconds, I'll get probably close to like 8 results out of it before it'll stop running. So this runs on a scheduler, which I'll get to a little bit later. Talk about how you can schedule your own stuff. So let's talk about some issues with dispose. Items can still be received after you call dispose. Just because you've called dispose on it doesn't prevent the events from being fired. They just won't be handled anymore because you no longer care. You should also never directly call dispose. I do it in that example just kind of for like academic reasons, but you really shouldn't at any point in time try to manually manage what's actively in the system. Because within Rx, you don't have states, so you don't know when something would be done responding. You don't know if the user could still use it, so you kind of need to trust the system on this point. And there are significantly better ways to stop receiving data from your user or from your event stream. So to do that, there's this thing called a DisposeBag. So it kind of applies ARC principles to Rx, in that once it's no longer referenced by anything, it can go away. Kind of like a simple idea, but if you look at things like Rx JavaScript, this doesn't exist. This really only exists in like Rx Java and Rx Kotlin, where it'll act as this ARC type receiver. Your DisposeBag will automatically take care of itself, but it's also okay for you to manually reset your DisposeBag, because ideally, if you're doing something like in a view model, you should add everything you can into that view model itself so it can respond in kind, or you add it to your view controller. And if, say, your view controller is refreshed or it's deallocated and you come back, it'll automatically handle teardown for you. And once you've added something to a DisposeBag, you cannot manually dispose of it. It just won't respond.
Is that like a single instance of DisposeBag, or do you have to like manually create it every time?
So you do have to manually create them. They don't exist because RxSwift doesn't know what needs to be grouped together. It doesn't know what's important to certain things. So it defers to you as the programmer to take care of that. So what you do is you declare it as an instance variable. Don't make it static, just let it be an instance variable, because say if your user leaves a view controller and comes back, and for some reason you end up with a second queued load, you could have some interesting collisions and then the app will crash. So what we do here is we take the same search result we had from before, and we're just passing it through. We're running through a filter, which is not an Rx feature, but it's a standard feature within the Swift library, which is pretty fancy. Big fan of that. And so you use it to drive like your next object. And so we'll say we've run into this limit exceeded event, and so we're going to show the user this alert. Then we're going to add our filter to a DisposeBag. So once we're done receiving events, this will now automatically tear itself down, because the system will know that we're done with events on this. This was either a cold observable that was just a one-time fire, and I should give that memory back to the system, or the user has left the screen that cared about it. RxSwift has this very cool idea for observing things called take until. So for managing your subscription, if something is added to a DisposeBag, but you're still expecting it, or you don't care about events past a certain point, you can automatically kill that through this take until method. So when you do take until, you're going to pass some Rx value in. So you can say, I want to know when this is deallocated, or I want to know when I've exceeded this many events. So once you've hit that number or that condition or that enumeration, it'll automatically stop responding for anything below that. And then you can, again, subscribe as if it was just a standard observable and do something with it. But everything I've talked about now is kind of observables of just one instance subscribing to it. But say you need multiple things. There's this idea of shareReplay. So if you're an observer and you're processing events, and say I have one service that's going to subscribe initially, but I have another one that's going to subscribe later. This would be like useful if you're doing things like playback of real-time data. So if you're doing like an event stream coming down from like sports scores, or you have something like that's more like real time, like say like stock prices coming down, shareReplay gets you a lot of value out of that. So let's all observers see the same sequence. So once I tell an observable that I want it to share its replay, it'll save those events and cache them. And then when another subscriber comes along, I'll just hand it that data in the exact same order I processed it and with the exact same delays. So in code, this kind of looks like this. I have the same like my interval function that just emits numbers counting up, and I'm going to share the replay once. So through my design, I've decided that I'm going to allow two subscribers to come along and collect this data. So we immediately add subscriber 1, who starts printing everything, and then no matter at what point we add subscriber 2, even if like the counter has stopped running, we'll still get that data back, because since it has a shareReplay function, it will exist in memory until it is done or deallocated by DisposeBag or by the deallocation of the app. So it's kind of a feature that doesn't have like a significant number of uses, but if you have multiple users, say you're writing Swift server-side code and you want to save events to pass through, and you can do that. This is pretty nifty, so it lets you cache your results as you pass them through. So inevitably, you'll run into issues where your Rx code will just crash for some reason, or something will fail and you didn't think it would fail. So let's dive into that. So observables all run on short circuit logic. So once one thing fails, everything cascades down and the system just fails. You can add catch or retry operators that I'll get into a little bit later to save your observer or your observable. And once you've kind of like saved it at that point, you deal with your error, but your event stream will keep coming. If you don't handle it, it just fails and it's done. So I highly recommend, if you think an error might occur or you think something might occur, just try to catch it and deal with it. Or if you're doing things like a network request, big fan of the retry operator. It's amazing what you get for just adding one line of code to your network call. As much as we all love Xcode, it is not great at processing Rx sometimes. It's more an issue with like Clang and the preprocessor. So sometimes we get compile errors that'll go through the app. Ideally, to kind of like work through those, try and get Xcode to like autocomplete stuff. Just kind of think about like a little bit of like, why is this happening, or if this is an error that I expect. Oh, so these are. I don't remember what I did. I had to rearrange my slides earlier.
You sure we're good?
Yeah.
The aftershocks from Japan.
No.
So this is kind of an example of the catch operator. So when you tell a request to catch an error, you're essentially just going to pass your observer through. So here we're observing JSON coming back from some API on Flickr, and say we've implemented Swifty JSON, so that we have the JSON object. We'll just return the first JSON that came through and move on. Oh, I had the same slide twice. Okay. Oh, sorry. That's what I meant to cover through here. Now I remember. So you can write the same thing multiple ways. So if this doesn't compile, it's because Swift didn't do the correct type inference. So you can start to add complete more. So you can add more to the filter. You can add more to your flat map. You can add more data to your error. If that still won't compile, you can just go out and basically tell Swift everything that's going to happen. And so you're going to explicitly tell Phi that, like, I'm going to give you a string, I'm going to give you a string, I'm going to give you an error, and eventually Swift will get it. As for catching errors on the runtime, you'll get something like this. So this call stack is probably like one of the nastiest things you'll see. This is all for an autocomplete, where I stopped it as it started to respond to the first change event. So since Rx is functional and kind of stateless, it just kind of calls itself wherever. So your memory usage isn't like at all higher with RxSwift or reactive programming, but it kind of makes doing call stack debugging a little hard. So let's talk about like how we resolve runtime issues. So we have this function that comes with the Rx Cocoa library that's bundled with RxSwift called debug. And so what debug does is if you add it to your observable call, when you go to subscribe, it'll add whatever text you want. So you can say like this subscription or this method, and it'll print out this as this runs. It'll say like whatever you wanted for debug, and it'll show you the result at that point as it went through that run through. And then the value that was actually executed and returned. So unfortunately, you kind of go back to print statement debugging. But since you now have significantly less code, you're in a much better state to do this. The other thing too is kind of like rethink your logic when you run into a runtime error. Think like, what could have happened here? What could I have done better? What did I not like code against? And so if you do one run through with your debug, it'll show everything. Remember to take this out before you put it in a production app, because anyone who connects their iPhone running this to Xcode will be able to see all your print statements, because they all log to the console. So how does RxSwift know when something changed? So it kind of goes back to KVO and essentially key value observation for those who aren't familiar. So system in Objective-C Objective-C introduced this idea of key value operation, but it's not type safe. It kind of just goes wherever. If you use NS Notification Center, it's kind of based on this. It's kind of dicey. Sometimes it'll work, sometimes it won't, depending on if what state your app is in, because it was built for a stateful system, but was not built very well. So since we now exist in RxSwift in a stateless system, we can use KVO to kind of observe everything we want and kind of bias all this runtime priority that Apple has already given KVO in the Foundation library. So we do this two ways, through Observe and Observe Weekly. So Observe is something that you'll do as just like your standard wrapper. This is kind of how you call it. So here we're observing a struct. We're observing the view frame, and we don't care if it retains itself. We'll let the system take care of that. So you use this when all the observed paths come from either itself, the caller itself, or from any of the superclasses that are instantiated it. And your property must be strong, so you can't use this with optionals. Use this with an optional that doesn't have a value, you'll get a force on wrap error, and Swift will very politely collapse your app. But you can also observe anything from your dependents because you act as super in that instance, and you call down. Rx Observe is probably one you'll see for UI observation or anything on the user interface threads, just because it exists at like a faster runtime, and user interface objects always exist. At no point in time will something that you added through interface builder or you declare as something the user will see be optional, because if you don't present it to the user, they can't interact with it. So, and UIKit will make sure of that. So UIKit will enforce a strong property type. On Observe Weekly, we kind of use Observe Weekly when you don't need to know immediately. So this is not a user interactions, it's like server interactions. It's not performant because the system will deallocate it if it's not being called, or if it's already been called and you don't want to care about it. So here, all we're doing is we're observing a bool type called behaving okay on a view controller. And if that changes, we'll find out, but we don't particularly care. We don't need to know immediately. You use this whenever you have a weak target or you have an arbitrary target. So with Observe, you need it to be directly related to the object you wanted to know about. With Observe Weekly, you can observe anything in the application because you existed at that point in the application memory system, not within your object's memory system. So earlier, we observed a struct. You need to use RxCocoa to do this. So RxCocoa comes with reactive Cocoa, or no, with RxSwift. So RxSwift comes with 4 libraries. It's reactive Swift, reactive Cocoa, reactive Test. Oh, and there's one more because I never use it. I think it's oh yeah, Rx blocking. Yes, Rx blocking is one that I appreciate, but I've never found actual use for. So, working with UIKit is probably something you'll do the most in reactive because reactive is designed to respond immediately or respond very quickly. So let's talk about threading. RxSwift will take care of most of your threading for you using the because it sits on top of the thread library. It'll take care of itself. And observables generally will return results to the UI thread. And you want to return API results on the UI thread because if you let them settle in the background, the system will get to it when it gets to it versus UI thread was immediate response. Your API call will not run on the UI thread, but the observable will. So your API call will get shifted through NSURL session through an extension that RxSwift includes. It will get shifted to a background thread, but your observable will exist on the main thread, so it'll continually check and listen for the response. So in RxSwift, this is called the MainScheduler, and so you observe on that instance. On handling errors with UIKit, you cannot bind a failure to a UIKit item. This will lead to another crash in the application. This is not through RxSwift design, it's more of just the design of UIKit. So when UIKit runs into an unexpected value, it fails through the Swift runtime. And observable might fail if you didn't use catch error and just return, or a sequence finished with an uncatched error. So make sure you catch your errors, or you tell your observer that in this instance, catch with error, and just return this value or do this. Sharing, you want to share descriptions from the UI layer if possible, just because you don't want to make the call twice. So let's say you made a network call to iTunes for what the top songs are and the top charts lists. If you come back to that page, you don't want to have to go back out to the iTunes server, re-download this massive JSON object, parse it, and redisplay it. You've already done that. And if you're coming back within like a certain period of time, I don't think the store updated that fast. So you just use shareReplay, and this will cache your network response if you use it in that way. It's also great for doing like intense calculations. So if you do like a Bezier path animation, you can have a sequence of those as an observable, and then you can replay the animation when they come back, but you've already computed all the values. So HTTP requests in RxSwift are probably the greatest use of this library. So you create your URL, you create your request, you pass it to this shared session, and then you pass it to this RxData function that's on the shared session. So this comes with RxSwift. It handles your request, and then you just do whatever you want with your data. We're doing a couple things that we did earlier here, where we're observing on the MainScheduler. We're subscribing to a UI image view, and we're going to present the image when we're done. And then we add it to our DisposeBag so that when it's done, the system will handle memory for us. So let me show you how this is done when you include error catching. So kind of a lot of code, but actually still more concise than doing things in a normal NSURL session or becoming an NSURL session delegate. So we have this Rx response that we got back from this URL request. This retry 3 is what I talked about earlier. So this will automatically retry your network request 3 times before it moves to catch on fail. And so if you've ever tried to do this before using the stock library for NSURL session or NSURL request, when that was the thing on NSURL connection, this is pretty fantastic. If you have like a shaky web service, or maybe you have an application that has a high web request volume and might not be able to respond fast enough, this is a lifesaver, and it's immediately bought on one line of code. We have this track activity function. So if you're doing a network request and you want to block the user from doing something, or you want to tell the user we're doing something, you can just add an activity indicator to that. And we're observing this on the background scheduler. And then we map our data as we see fit, matching against status code, trying to unwrap JSON, passing it to objects. And then there's this retry on becomes available. So this is in the RxSwift. Yeah. I activated the touch screen. I touched it. So retry on becomes available is a pretty cool service because it talks to reachability. And if reachability says that there's no internet connection, it won't even try. It'll say, we're going to return an empty string, and we're just going to say the service is offline, we can't reach it, or we have no internet connection. And you just then handle that retry, and then as soon as network becomes available, if the user is still on the screen or in the app, it'll try the network request and try and bring that data back for them, which is really cool. So a lot of stuff that I've shown you here is in this library called RxDataSources. So I incorrectly put this in bundle with RxSwift. I thought it was. It is now its own project. So you can just Carthage install or CocoaPod install, whatever you see fit. This adds data sources for your UI table view and your UI collection views. So you can make those respond to reactive events natively. Let's talk about some schedulers. So I've used a main thread before and a background thread. And RxSwift has two implementations. It offers some serial schedulers and concurrent schedulers. So if you've ever taken like a programming class before, done any multi-threading, kind of behaves the exact same way. Except concurrent will automatically respond to observe on and subscribe on, and will ensure that every function is called as intended. And if you do a serial request, Rx will do some optimizations where if you're saying doing concurrent network requests, they will all fail independently. If you have network requests that are dependent one after the other, it'll do short circuit evaluation, or it'll try and optimize so that if it thinks a call is less memory intensive, it'll try and run it faster. So you get 5 schedulers from the reactive Swift, the RxSwift library. You get current thread, main thread, serial dispatch, concurrent dispatch, and operation queue. So current thread is whatever thread you're using. This is what's there by default. So if you don't specify a thread, this is what it'll run on. Coincidentally, if you're in your view controller, your default thread at that point is the main thread and the UI thread. So just be careful with that. This is a serial scheduler, so it'll start to perform optimizations as possible, and it'll just act as a queue. So if things start to become unreachable, it'll cascade that down. And it does immediate execution, just as your normal operation queues would. Your main scheduler is, of course, a serial scheduler because it's provided from the Foundation API. Only use the Stuff API or the UI. If you have network API requests, still subscribe and observe them on the UI thread, but they will not. But make sure they don't run on the UI thread. Serial dispatch. So serial dispatch is kind of just kind of like standard abstraction to I want a separate queue and I want this queue to run whenever. This also takes concurrent queue data and will make it serial. And then the main scheduler itself is an instance of serial dispatch. The one you'll probably use the most, actually, is this operation queue scheduler. So operation queue, if any of you have ever used NSURL or NS operation, it kind of works in that same idea of I have this chunk of work. I'm going to pass it off to this background scheduler that's going to take care of it and run it whenever the system has resources and time and isn't responding to a user tap or user input. It's fully concurrent, so any work queue that you pass in or any observable you pass in as data is found, it'll create parallel work jobs to run for that. If you're doing like large computations, so say if you're running like an instance of like Photoshop or any Adobe Suite product on that, most of that is done through MS operation queues. This one is different though, because you can actually specify how many work threads you want to provide to the system. So if you have just big chunks of data that's parallelizing gets you gained to a certain point, you can tell it, I want you to create threads to this point. And so you can kind of like fine tune your algorithm a little bit. So let's talk about testing. On our team for Amex Mobile, we're all about testing. TDD, essentially it's TDD or die for us. So RxTest comes with RxSwift. It is an extension of, it's a delegate of XCTest case. So it kind of implemented it the same way, so it's access to the test suite runner within Xcode. That's kind of where the comparison ends. You don't need setup, you don't need teardown, you don't need performance tuning, you don't need any of that. Essentially, this is what you need to do. So this is a test extension for testing if something is hidden or not. So this kind of, this is actually from the RxSwift project's test themselves. This is their extension for UI view. So we observe our subject, we pass it, we initialize it as we see fit. We use this observable just to subscribe to our UI view to see if it's hidden, and then we dispose of it. So this idea of just. Just is an observable that returns once and then exits. Or returns whatever you pass in for that one instance that you want it to return this block object. Or you don't want to have it respond to the events. You want it to be a finite stream of events. Essentially, what we're doing here is kind of just enforcing that we've done this observable, we've told it to be true, we are changing this event on Rx hidden, and then we're disposing of it because it's a test and we don't particularly care. So we then assert that it's true, kind of as if you would for any standard unit test to make sure that your values didn't change if you're testing a view model or any other business logic object. Let's go to a more advanced test. So here, the scheduler exists as this idea of a test scheduler within RxTest. So we are able to set how fast we want it to emit events, or if we want it to just emit our events all at once. So it's kind of what we've done here by setting its clock to 0. We've created this idea of a hot observable that we talked about earlier, where it exists once and anything can respond to it, and it has more than one event. We map it, we do some transformation to it. We tell the system what the correct messages are going to be. And then we, again, use XCTest to verify our values. So this isn't terribly exciting or terribly different, but it's important because, as you saw through the call stack earlier, trying to trace your values can be pretty difficult. And with most other functional libraries, you can't really test your code. You kind of have to do like black box testing or just standard user testing and just tap the screen until something breaks, which isn't great. You don't know very quickly. The test suite for RxSwift on my laptop compiles and runs everything in about under 5 seconds for all the unit tests. So you have, this project has close to 97% test coverage. So they've built test first, and they're really big on it. But what they provide that I have not seen any Rx library provide before is probably like my favorite thing. It's this idea of Rx marbles testing. So what we do here is we have these events that are going to come through. We create our event stream. Each one of those letters is essentially a value that's declared up top as a certain event. And we let it handle this event stream. And then we'll tell it what we want the result to be based off this event stream. So essentially, through Rx marbles testing, you can verify how event streams will be handled within your application. You can see what's going to respond to what at what time, using the same scheduler we had before. And overall, it's just a very impressive implementation of what can be done. So sadly, I did have a demo, but the web API I was calling was for petfinder.com, if any of you have used that before. And a life before I was a software engineer, I worked as a, before I was an iOS engineer, I worked as in an operation efficiency department doing shortest past algorithm design for PetSmart Corporate, and they were super big on adopting dogs and dogs everywhere. So coincidentally, I'm a bigger dog person than I was when I went in, so I was going to do a demo on how to find adoptable pets, but their API died yesterday. So sad. So,
How convenient.
yeah. So I will be uploading a revised version of the talk for code I'm going to walk through later. I'm going to go comment it more since you guys don't see it running. But that should be up later this week. At the front of the talk, I put my Twitter handle. So if you don't see it up in a week, you can feel free to harass me and ask for it. And on
Take
that
care
note,
of that.
yep. On that note, do you guys have any more questions? Anything that Rx has not, that I haven't covered, or anything?
Well, actually, do you have a book you recommend or some kind of online class that would explain reactive programming in general?
So if you go to, I think it's reactivex.org. So RxSwift is an implementation of the ReactiveX project. So the syntax is very JavaScript-y or Java-y in general. This was done on purpose. If you've ever heard of a library called Reactive Cocoa, that was the probably first implementation of reactive on iOS, but up until recently it was Objective-C only, and they tailor their calls.
I think it's reactivex.io. Maybe.
Maybe, I think it might be done. If you Google
The dot
ReactiveX,
yeah.
it comes up. So like inevitably the comparison comes between like Reactive Cocoa and RxSwift. Reactive Cocoa has recently been rewritten entirely in Swift, so it's a little bit better in that aspect. That it has like some legacy Objective-C support. RxSwift does not care about Objective-C code at all. It was actually something they tried originally right after RxSwift 1 came out. You can actually go to their GitHub page and you see it as an abandoned branch on their project because they gave up on it because they didn't think it was going to be worth value as Apple. If you watched the WWDC talks from last year, the only talk that was presented in Objective-C was the one on multitasking. So that sends a pretty clear message on the direction of language. So I recommend their website because it's the same calls between RxSwift, RxKotlin, RxJava, RxJS, and a bunch of other projects. So it's the same syntax all around.
In terms of the network calls, you said that it requests 3 times before it goes on. How much time in between before it makes the second request? Is it like,
It's like immediately on fail.
okay.
So that retry only runs on fail. So if you hit your catch fail and there's a retry, it will go back up and retry again. Or if there's an unhandled area, it'll still go up and retry again.
Like, as a real world example, can you kind of talk through what you would have demoed?
Yes. So I was going to demo network requests and JSON parsing. So actually, let me see if I can find what I was going to do.
The Wi-Fi is N Central 5G. The password is let me in now. Number 1. Yeah. All lowercase.
Let's see. Well, actually, I'll show you one of their examples because mine is not as well commented, and that's a shortcoming on my part. So where is it? So this is from their examples, because it's a little bit better documented than mine. So they provide an example of an API for searching repositories on GitHub. So they're really big on structs for all of your objects because structs exist in memory. They can be cloned, they can be moved around, created, destroyed. They don't have the same dependencies that a class does, but structs can still adhere to protocols, so you're in pretty good shape there. They're big on when you make a network request, implying a service state, if it's going to be online or offline, and then creating an enum for parsing your network response for either things that have been found. Oh, that's so tiny. There we go. Oh, God. Thanks. So they've kind of adhered to, if you watch the Swift talk from this past AWC protocol-oriented programming that was put on, they are super adherent to that since that's how Swift has kind of forced them to exist. But they also seem to really like it because they deliver faster than any other Rx project right now on changes. So they create this idea of a list of repositories as a struct, so you can maintain, so they can kind of like pass that around. Maintain this idea of service state that was declared earlier. They also handle if the limit request was exceeded. So GitHub does, if you try more than 10 API requests within a minute, it blocks you out for a little while and then they'll let you back in.
Denial of service prevention.
Yep. Yep. So they create this API. The one thing I've noticed in their code that I'm not entirely sure why I understand the reason behind is they're super big on extensions. So they'll create this class here talking about how they'll do a GitHub API search, and then how they'll handle the activity handle indicator, and how they'll present that on the application UI layer. And then they'll just start extending it to add functions instead of putting it in the same place. I think for documentation's sake, it makes things easier. Yeah.
My bad, Chris.
That's great.
My bad, Blake.
I blame Chaz now.
Well, yeah, but
No, that's the legal team.
that was actually.
When did you request it? The admin rights.
Oh no, that goes off all the time. I still have some
Every 15 minutes already.
every 15 minutes.
Oh,
Yeah.
just a,
You can request admin rights
Perception,
for
right?
15 minutes and they supposed to revoke it.
But if you have pseudo rights, you just change it, so it just goes off all the
so
time.
you just get the alert anyway.
Pipe down, Blake.
So here's how they kind of like do a search. So when GitHub gives you a result, their API is not fantastic. It's responsive, which I'll give them that for, but their results don't come back great. So they create this idea of a search function that's going to return an observable of repository states. They create their URL, they have their search query, and they hand it down to this recursive search. So when they start doing a recursive search, if they get failures, it'll retry for them. They do everything off of the flat map, and they return the same observable repository state. And they just start parsing everything through. They're also very big on cases, which I am very, very big fan of. Swift cases are fantastic because you can switch on anything. So they switch on if there's a next repository. And then they return this observable using jest to say only these repositories are returned. And then they declare this idea of like an observable never if they're waiting for page load, just so nothing on the UI will react. And then they begin processing the next page, and then they all concatenate them together. And then they have this a separate function for how they actually get the search result URL. When they create their response, they have a retry 3, retry activity, and they observe on the schedulers. And then they have this fancy parser to deal with Git Markdown that hopefully no one else has to deal with.
So the dog app was that going to leverage this?
Yeah. Parts of it, yes. because they, in their example, have produced some handy extensions that you can use.
How big is the support community?
They're pretty fantastic, actually. So I think there's 20 or 30 people who maintain the project right now, but either they're very dedicated or they don't have much else to do with their time. Because if you go to their issues log, you'll usually see a response within like an hour or so.
Just nothing better to do.
I think a couple of them. I'm pretty sure like 4 of them are like high school students. Yeah.
Well, that explains it.
They write good code. Their tests are valid if you go through it.
I believe you.
As far as like results that you'll find on like Stack Overflow, pretty fantastic actually. There's been quite a lively discussion between this versus Reactive Cocoa, and a lot of people who were on the Reactive Cocoa project or implementing it in their projects have just not been thrilled with the Reactive Cocoa project as it's come along. Or there are people who are converting to iOS now that Swift is around, and Swift is very much easier to pick up than Objective-C ever was. And so you have a lot of Java programmers coming over who are writing Android apps or server-side apps or JavaScript developers. This is the exact same syntax. So any language you go to that's implemented through Rx, it's the exact same syntax for every call. So it's very easy to pick up and move along. So you don't have to worry about dealing with like the local language difference as badly.
Is there any type of application that would be that reaction would be inappropriate for? Either because of performance or just difficulty of managing it?
I would say doing like large data processing is not great for reactive. So if you have something that's going to, you have like very like computationally heavy apps. So say you have like an Adobe app, like a Creative Suite app on the iPad, or you have Autodesk on like the iPad Pro. This wouldn't be great for that because you'll have instances where if you don't like manage your observables properly, they could live on much longer than you intend because you don't have a traditional UI.
It's my legacy work.
Yeah. It's also not great if you're not responding to a user interface. If you're dealing with things that like you just have like a batch processing job, you can get probably more done faster using objective orientation or an imperative design because you don't need that fast response. You just need data to be crunched. Rx is really like ideal if you have user interaction. So like one of the guys who just joined our team used to be the lead engineer for GitHub for Mac. And so they implemented that in Reactive Cocoa.
Who's that?
Matt Deephouse. He just joined. And they chose to do reactive for that environment because they still want the user to have a responsive application, and they want to be able to very easily background your GET request calls, your networking calls within the GET binary. If you don't have a user interface, you don't have like something that's going to change very often, say you have like a legacy application that you're not trying to change too much, you're not going to gain too much from reactive. Okay. Anyone else?
Yeah, quick question. So I read a couple blog posts that you mentioned that Swift isn't like functional at all. What do you say about that? And how important is it to kind of learn this? You know, should you just stick with the object-oriented and then protocol-oriented, or just jump into functional coding?
So they can all kind of live together. There's a more advanced topic that I didn't think I had the time to get into on this idea of you can leave the Rx world and come back. So you can have an Rx object that talks to a non-Rx object and handles that. It's not particularly great. You have to be kind of careful in how you implement it. I personally think Swift has a lot of functional features. Scala was a big influence on Christian Leitner as he put it together. So it's definitely something that played into their feature design, and it's definitely something that they wanted to have, which is why you have playgrounds and things like that. But it's not necessary for you to learn things like Rx. It's a very cool pattern. It's a very cool implementation. But if you don't have like the need for a fast user response, you don't have the need for like multiple network retries, you're perfectly fine implementing in the stock objective-oriented way or in the protocol-oriented way. It's just a different perspective.
Besides debugging, what would you say was kind of the biggest hurdle to?
Probably thinking in streams. So I experienced this a little bit because before I was a full-time iOS dev, I was doing a lot of C#. And C# is very, very functionally driven. And the original Rx project actually came out of C#. So and if you've ever used like Link, that's kind of functionally driven. And so it's kind of like changing your mindset of like, this isn't event, this isn't like a state that I need to care about. I just need to handle the user input and deal with it correctly. You get so into this like zone of like, I need to draw this, I need to import this table view. So I'm going to go and say like new class, UI table view controller implements these delegate methods for you. And you kind of just get in that zone. So just kind of like breaking that mold and trying to see things from a new perspective. It's just a little bit different. Or if you have like existing code and trying to shoehorn this in, that was I tried that as like an experiment to see if I could put this into our app. And since we're still so Objective-C, it's kind of painful.
How would you have implemented this into your app?
So our app has probably most of the legacy features that you hear now as like anti-patterns for things that you just like should not do. So since RxSwift can only like talk to Swift objects, we basically use it for like anything we implement as like a new feature, or anything that we can do like entirely segmented for the rest of our code base, which at the same time we want and don't want. Like this would be perfect for redoing how we call our server backend.
Mm-hmm.
Just because we get free
Just in
retries.
general or for a specific function?
Just because we will sometimes in like our debug environments will get server not responding, not because the server's actually not responding, just because something happened along the way.
Yeah.
And it's just like an inconvenience.
So a retry.
Yeah, so retry would be perfect for that. Also being able to reactively or to immediately map our results to what we want to do. So versus potentially processing like large JSON or XML files, we can just kind of parse those out very quickly, constructing any view models or structs that we need to, and just pass those along. And let the view controller or the separate view model deal with that.
There's that Morphing website.
Yeah, so
Actually, it's a lot.
yes. What? Let's see. Which one was the Wi-Fi?
And Central 5G. Let me in now, and the number 1.
Sure. Don't do it.
I came straight from the office, so
It's it. No, the path URL. It'll just circumvent it if you can't communicate with it.
really?
Yeah, you know that.
I don't
Good
know.
enterprise.
Legacy Blake.
Good enterprise.
It's it. Yeah, so Blake, if there's a pack file involved, it'll if you can't see it, it'll circumvent it.
Okay, so this is kind of like a cool way to visualize it. So this rack marbles kind of applies to all operators within the Rx family. So not all these have been implemented for our RxSwift yet, but they're getting very close and working very hard towards getting to them. So you can look at examples for like zip. So if you use a zip function, it takes 2 subscriber streams and combines the 2 values and creates a separate stream for you to view. Or distinct until changed, and you can kind of drag these around of just like, I have a 1, I'm going to move it over here. and you can kind of just see, like, visualize, like, what outcome am I going to get from this. So this is another, like, very cool project to kind of just, like, take a look at and understand. And even, like, the math functions applies for you, so you can immediately, like, get an average back from an event stream of integers or numerical values. And there's more that this website's trying to implement, as well as the Rx project in general is trying to implement. They have some that people have requested or people submitted pull requests for, and then as you're taking their time to evaluate them to see if it's something that, like, the project as a whole should take, not just individual implementations. So RxSwift builds to this spec. So you can handle, are all of these true? Or you can look for an includes value, and I find it will continue to pass until less than true. So it's pretty cool. It's a fun way to play around and kind of visualize, like, what's going on.
So a quick question: in terms of like spending your time on learning a certain way of thinking, like, do you recommend just learning more about protocol-oriented programming? Do you recommend learning more about functional programming? Like, what's more important in terms of getting really comfortable with architecture in your program in that way?
For Swift, if you're going to do Swift as your primary language, protocol orientation is huge. It was made very clear.
Yeah, by Apple, right?
Yeah, it was made very clear by Apple, and it's also made very clear if you ever now Swift's open source, you can read the discussion emails on features they want to add to the language.
Right.
And it's very clear that protocol orientation is something that they will not budge from.
Gotcha. And how do you have any resources to learn more about that? Because it feels you search online, there's like no resources.
So protocol orientation is kind of like a brand new idea.
Right.
There's a WWDC talk.
Yeah, I've seen that one.
Okay.
Right.
If you look through the source code they provide with that, the crustacean code project, it gives you a pretty good example of, like, what's going on.
Okay.
Or you can take a look through the RxSwift code base, since they've implemented everything essentially as close to protocol oriented as they can. Good job,
Isn't the
Chris.
standard library right now?
Yes, parts of it are. The majority of the standard library is actually still in Objective-C.
Just going back to reactive programming principles, am I understanding this correctly, that all the events that occur are distinct and it doesn't matter what order they occur in as long as they've reached a certain point?
As long as, so in the functional stream, unless you told it not to care about certain attributes of events, it's going to pass you everything until either you stop subscribing or you then recreate and say, like, I don't care if they're not distinct, I don't care if they're, like, less than this value, I don't care.
What if order actually does matter? Then there's some way to.
So you can capture an event stream into, like, a non-Rx data structure and then change it however you want.
So you do some Rx and some not.
Yeah. So if you need to, like, capture an event stream and you want to reorder it, I don't think there's a function for it yet, but I would just say pass it back into some kind of array and then just sort based on whatever your conditions are.
Question on the, did you ever see the Objective-C.io book, Functional Programming?
I actually have not had a chance to read it.
Okay.
It is on my to-do list.
I was going to ask whether that kind of teaches us in a way as well, or not. It's completely different.
So the recommendations that I've read for, there's a couple people in our office who've read it, and they said it goes into a lot more detail than you'll see from, like, certain projects, because it covers Rx as more of a philosophy from more of an academic standpoint and an implementation standpoint.
Gotcha. Okay.
So they'll write, like, their own custom functions within Swift library to show you how to do functional programming. But it isn't my to read this, so we'll hopefully be able to redo it in the next couple months. But good heads down.
All right. Well, thank you, Blake.